Okay, welcome to the actual review video for Unit 2. The graph of the function f is shown at the right. Find each of the following. So if I'm looking for f of 0, that means that 0, normally it's written as f of x. So that means that where x used to be, there's a 0. So my x value is 0. So if I don't go left or right at all, that's an x value of 0. Where do I have to go to get to the function? Well, up 1, 2. So the y value that goes along with that is 2. So f of 0 equals 2. Okay, so another example, f of negative 2, so this time they're telling me again it's in place of x, so I need to go back 2, so back 1, 2, and then in order to get to the function I have to go down 1, 2. So my f of negative 2 is negative 2. And the next one, if I have f of x equals negative 2, find x. So this time I know they didn't give me x, so they had to give me y, and that makes sense because f of x is just a fancy way of saying y equals. So if the y value is negative 2, that means that I'm going to go down 1, 2. Well, if I look for the function, I can go left 1, 2, and there I hit the function. So that means that one x value is negative 2, but if I go right, I can also hit the function over here. So how many to the right is that? That's 5. So for this one, there's two x values that have the same y value of negative 2. So when that happens, remember that we have to write it as a set. So it's the set of values, negative 2 and 5. Those are the x's that go along with it. Okay, domain. So how do we find the domain? Well, we have to look from the left side of the graph and then see where the first time we touch the graph is. So if I'm going along, the first time that I touch it is right here. Well, what x value is that? The x value, remember that's a left or right movement, so the furthest left we go is back 1, 2, 3. So we start at negative 3. And then it's continuous, so that means that we're going to say, okay, it starts at negative 3, but where does it go up to? Well, if I follow my function along, I see an arrow to the right. So that means that it's going to continue this way forever. So I write that as infinity. So I say I start at negative 3 and I go up to infinity, but what do we notice there? Well, this is an open circle, so that means negative 3 is not included. So what do I have to put around that? A parenthesis. And remember that infinity means that it's going on forever. We can't actually touch that. So again, we'll use a parenthesis around there, and hopefully you can make yours look a little bit better than mine. It's really tough on the iPad. Okay, so now we have the range. So what's the lowest point of our graph? So if I'm going along from the bottom here, well, if I'm moving up, I see that the lowest, I hit the function right here. So what value is that? That's down 4. So you just count them down 4. So I start at negative 4. And again, if we want to do it all at once, we can say, okay, it's an open circle, so I'm going to put a parenthesis around that. And you can do it either way, the way that I did it here, which is just find the left and right and then decide if parenthesis or bracket, or do it in this way, deciding right away and writing negative 4, the lowest that it goes. Then if I go, okay, well, the highest that I see is right here, but wait a minute, over here I see an arrow. That means that even though it looks like it's going out, it's still going up too, so it's actually going to go up forever. So the furthest right it goes is infinity. And again, infinity is not something I can actually touch, so we have to use the parenthesis. Okay, so function, explain why or why not. So is it a function? Well, remember we can test by saying, is there a vertical line that goes through and touches this function in more than one place? And anywhere we put a vertical line, that's not the case. So in other words, no x values repeat. So I can say that yes, it is a function because the function passes the vertical line test, so none of the x values repeat. All right, let's look at the next one. So this question says, given the relationship, and we have this set of points here, negative 5, negative 2, negative 3, 1, negative 3, 3, 0, 4, and 2, 4. Explain why this relation is not a function. So they're telling us that it's not a function. Why is that the case? Well, if we look up here, I can see that the negative 3 repeats with two different y values. So I can say that the relation is not a function because the x value of negative 3 repeats. So each x is not paired with one and only one y value. Okay, so what is the domain? Well, remember, domain, that means x values. So I just need to say what are the x values. And since they're specific points, it's not continuous in between. So I just need to list them out in set notation. So my domain, all my x values, listed from least to greatest, is negative 5, negative 3, 0, and 2. So remember, these always have to be in order, least to greatest, and we don't repeat x values. If they're already on there, we don't write them again. Okay, the next one, if p of x equals 2x squared minus 7 divided by 4 minus 3x, what is the value of p of negative 1? Well, remember it used to be p of x, now it's p of negative 1. That means negative 1 is in place of x. So I'm just going to substitute it in everywhere I see an x using parentheses. So first what I did was just rewrite it, substituting in. So everywhere I saw an x, I plugged in a negative 1, substituted that in place of x. Then, in order to simplify this, I need to simplify the numerator and denominator, and then finally divide at the end. So if I put this all in my calculator, 2 parentheses negative 1 n parentheses squared minus 7, it'll give me the new numerator, which is negative 5. Now I need to go ahead and clean up the denominator. Again, putting it in my calculator, 5 minus 3 parentheses negative 1. Be careful, I know these kind of look like negatives, but it's supposed to be a minus because it's connecting these terms here. So minus 3 parentheses negative 1. If I do that all in my calculator, I get 8. And then finally, we divide negative 5 divided by 8 in our calculator. And since we get a decimal, we have to hit math frac to put it back as a reduced fraction, and we get the same answer back. So this actually is our answer here. Okay, the next one's a little bit different because it says given p of x equals negative 2x plus 2, find x if p of x equals 24. So remember that when we see that p of x, that is a fancy way of saying y equals. So I'm going to substitute that value in place of my y. So the 24 needs to go in place of y. So I've done that there, and now I can go ahead and solve for x by getting the 2 away by subtracting 2. And if I subtract 2 from this side, I have to subtract it from this side as well. So then I get 22 equals negative 2x, so 24 minus 2 gives us the 22, negative 2x comes down. To get x by itself, now I need to divide, these are connected with multiplication, so divide by negative 2. And again, if I divide this side by negative 2, I have to divide the other side by negative 2 to keep it equal. 22 divided by negative 2 is negative 11, and now we have x by itself, so this is our answer, which makes sense because they told me to find x, and I found an x value. If you end up down here with a p of x equals, that would be a y value. That would not make sense. Okay, let's try the next one. Okay, the next one says that Horizon Cell Phone Company is promoting their new cell phone plan, which has a monthly flat rate of $30 and charges 2 cents per text. We need to write a function. When we see that word function, that means we need to use function notation that represents the monthly charge m in terms of t. So m in terms of t, we write that as m of t in function notation equals, okay, well, we'll charge a flat fee of $30, so $30 no matter what, and $2 per text. So $2 per text, I'm going to write first so that we're in standard form. But since in this question they said we had to use t, I wrote 0.02 t, and then we're going to add that $30 monthly fee. Okay, so that's my function there. Then the next part says find the cost of sending 540 texts. Well, now instead of being t texts, it's 540 texts. So t equals 540. So if I know what t equals, I can just plug it in place of t. So the cost of 540 is 0.02 times 540 plus 30. Then we can go ahead and put that in our calculator. And we get this 40.8, but this is a real life question. So they're asking find the cost. Well, to write that as a cost, I'm going to say $40.80, and that's my final answer for this question. Okay, next question. This one says that we have C of P equals P squared plus 3P minus 5 when P is less than or equal to 10, and then we have 3P when P is greater than 10. So we need to find the following. C of 10. Well, the 10 is in place of P, so I'm just going to substitute it in. But what's different about what we've done in the past is I have to decide which one to substitute the 10 into. So 10 is my P value. Is 10 less than 10? Or I'm sorry, less than or equal to 10? Well, yes, it is, so I'm going to use this function. So I decided I'm using that function, so I just substituted 10 in place of all the p's. So 10 squared plus 3 times 10 minus 5, and we can go to do that in our calculator, and we get C of 10 equals 125, and that's our answer there. Okay, so let's try another one. C of 0, well again, 0 is the p, but which one do I substitute in for? So is 0 less than or equal to 10? Well, yes it is, so I am going to use this first one again. So again, I just used parentheses around it and substituted it in place of p, so 0 squared plus 3 times 0 minus 5. Then we can go to our calculator, and we get our answer, which is C of 0 equals negative 5. Okay, next one, C of 20 this time. Well, is 20 less than or equal to 10? No, it's not. So then we have to go to the next one. Is 20 greater than 10? Yes, it is, so we're going to use this piece here. So remember that we use the different functions depending on which one our domain falls into. So C of 20 equals, and then we just substitute in 3 times 20, because I put it in place of P, and if we do that in our calculator, we get 60. So C of 20 equals 60. All right, next one. Subtract this from this. So when we've got from, whatever follows the word from needs to get written first. And then we have more directions. Then we need to multiply the result by negative 3x cubed. So first I need to do the subtraction part. So in order to do this, I have to write what follows the word from first, and then subtract all of that polynomial here, the trinomial here, 3x to the fourth plus 2x cubed minus 7x squared. So in order to do that, I need to first distribute this negative to everything in parentheses, because it's subtracting every part of the trinomial, not just the negative, or the 3x to the fourth. So when I do that, it becomes 7x to the fourth minus x cubed plus 7x squared minus 3x to the fourth minus 2x cubed plus 7x squared. Then I can go ahead and look and see where if I have any like terms. So I'm going to highlight them here for you so you can see. So if I look, okay, 7x to the fourth, that's like term with negative 3x to the fourth. And remember, the sign that's in front of it always is what puts them together. So 7 minus 3 of them equals 4x to the fourth. And then I see that I have a negative x cubed and negative 2x cubed. That gives me negative 3x cubed. So when I write it now, I've got 4x to the fourth minus 3x cubed. Okay, and then I keep looking for the like terms. Well, I see a 7x squared and another 7x squared. That's going to be 14x squared. Okay, so now I've done the subtraction, but this had a second step to it. It said then I have to multiply the result by negative 3x to the third. So now I have to multiply this result by the negative 3x to the third. So I'm going to write that by putting this in parentheses and multiplying by that. Okay, so when I multiply everything by this negative 3x to the third, that means that I need to distribute this to everything inside. So negative 3 times 4 is negative 12. And then I've got the x to the third times x to the fourth, add the exponents, so that becomes x to the seventh. Okay, then I have to do the negative 3x to the third times negative 3x to the third. Negative 3 times negative 3 is 9. And then I've got the x to the third times x to the third, add the exponents, so that's x to the sixth. And then lastly, I've got the negative 3x to the third times the 14x squared, and when I multiply negative 3 times 14, I get negative 42. And then we've got x to the third times x squared, that gives me x to the fifth. Okay, so then this is my final answer here. So remember to make sure that you did the subtraction, and from whatever followed that goes first, and then we had to multiply the result by this negative 3x to the third. Okay, let's go to the next one. Okay, this one says, Samantha claims that the graph below does not represent a function. State whether Samantha is correct and justify your answer. Well, if I look here, anywhere that I look to put a vertical line, even at this point where it's an open circle here and closed below, that means that it's not a point here, it is here. So that still does pass the vertical line test. So the question is this a function? And I think it is. So she claimed it was not. So I'm going to say that Samantha is not correct because the function passes the vertical line test. So every x is paired with 1 and only one y value. Okay, this next question says that Chase has incorrectly simplified the expression below. Explain in words exactly what he did wrong and correct his error. So if I look here, I see, okay, I've got a trinomial being divided by a monomial. So Chase decided to do pretzel method by circling each term and dividing them. So negative 36 x to the third divided by 9x, which I can look up here to see, is negative 4x squared. Okay, so that's right. And then I've got negative 54x squared divided by 9x. Well, negative 54 divided by 9 is negative 6. That's what he has. X squared divided by x is x, so I agree. Then if I look here, negative 9x divided by 9x, that's negative 1. Oh, so he's missing the negative 1 here. So here's my correction. I've corrected it. And now I need to go ahead and explain in words exactly what he did wrong. So I'm going to say that Chase thought negative 9x divided by 9x equals 0, but it is negative 1, because anything divided by itself is 1, not 0. In this case, a negative divided by a negative, or by a positive, is a negative, so it should be negative 1. So the most important part of that, I kind of went over what I needed to, but the most important here was that Chase thought that it was, when we divide anything by itself, it was 0, but it's actually a 1 or negative 1, depending on the numbers. Okay, so now let's do the very last one. Simplify and express answer using positive exponents only. Okay, so first I see this to the fourth. That means that I want to start by expanding this out and writing it 4 times. Okay, so all I've done is written that out 4 times. Now I can go ahead and do the multiplication. So 4 times 4 times 4 times 4, that equals 256. And then if I look, I've got x squared times x squared times x squared times x squared. That's 2, 4, 6, 8. So x to the 8th. Okay, keeping going, I've got y to the 3rd. So that's 3, 6, 9, 12. So now that's y to the 12th. Okay, then I'm still being divided by that 16, x to the 15th, y to the 6th, z to the negative 2. Okay, so now I've still got all of that. Now I need to divide. So 256 divided by 16 is 16. And then I've got x to the 8th divided by x to the 15th, 8 minus 5. That gives me a negative 7. So that means that I need to move it to the denominator. So remember, that doesn't mean that I changed anything with what 256 divided by 16 was. That's still 16. Just the x needs to move because that would have been a negative exponent. Okay, so y to the 12th divided by y to the 6th, 12 minus 6, that gives me y to the 6th, so I can put that in the numerator. And then lastly, z to the negative 2 needs to move to the top, so that becomes z to the 12th, to the second in the numerator because it was negative in the denominator. All right, and then that is my final answer for that question. Okay, so good luck on your test.